So Neil and Maurita Stueck, Neil was an alumnus from our department in civil engineering at the time, envisioned bringing worldwide scholars on really critical topics of our time to our students. So thanks to them for endowing this position and allowing us to lure in some preeminent scholars in our time that are working on some of the most critical topics of our society and what we're facing. And I'm thrilled today to introduce Dr. Don Wuebbles. Dr. Wuebbles was professor and chair at the University of Illinois for over 27 years. And in that time, he worked with IPCC, the International Panel on Climate Change. And with his work, they were awarded the 2007 Nobel Prize. So really some outstanding work that was instrumental at that. I asked what's another couple things that you'd like the audience to know as he steps up. And Don was advisor to the White House on climate change topics for 2 years as well, while he was still a professor at the same time, so kind of in addition to his day job as well. And the other thing he asked me to say was he's a farm boy. He grew up 50 miles east of St. Louis in Carlisle, Illinois, and is a lifelong Cards fan as well. So he's over the game this week, and he's coming to share he's not over the game yet, but he's going to share a little bit of his insight to one of the biggest topics we face today. Thank you, Don.
He mentioned the thing about phones because when I was at the White House for my 2 years, I got up to make a major presentation at the White House on climate change, and of course I get into about 3 or 4 words and my phone rings, only I had left my phone back in my office, but I had just the day before bought an Apple Watch, and the Apple Watch was ringing, and I didn't know how to answer it because I just bought it. So it was very embarrassing. Everybody laughed, and finally I figured it out and turned it off, but boy. So today I'm going to give you a little bit overview of the science, just a touch of the science, and then we're going to talk about, what do we do about this problem and the issues we face in trying to figure out solutions. And that's where I think the real debate, there really should not be a debate about the science. The science is well enough understood, but we know this is one of the most serious issues facing humanity now and for the decades to come. But we need to figure out how to get the right solutions to it, and that's and we really need to have the right debate about how to do that. So let's get into the science. We're all familiar with all the many extreme events that are happening related to the changes in climate because of the so, for example, we're seeing wildfires and extreme heat events, particularly this year in the western half of the United States. And at some points, it seemed like the entire western half of the United States was on fire. And it's because of the drought that's going on there, very serious drought that is growing, the extreme heat, the warmer temperatures leads to drier soils, and the plants are drying out, and if you get a fire started with sufficient winds in the area, it can just eat up huge amounts of acres. And so that's happening not only here, it's happening in Greece this year. Winter ago, it was our winter, it was in Australia. Many other parts of the world are starting to see a very serious problem with wildfires, Siberia and other places. Heavy rainfall. A warmer atmosphere holds more water, and as a result, you get larger rainfall events, and we're seeing increase in flooding in some areas because of that. Not quite as bad this year as we've had some other years, but we did see some very serious events related to major storms. Hurricanes are becoming more intense, and as a result, we saw major flooding in Louisiana and in New York, New Jersey area. I already mentioned drought, mentioned wildfires, and that hurricanes are becoming more intense. So every year there's somewhere between 10 and 20,000 papers written about climate, the Earth's climate, and published in peer-reviewed science journals. And so starting about 32 years ago, the countries of the world came together through the UN and formed the Intergovernmental Panel on Climate Change, with the idea that they would bring the scientists together to evaluate what is happening to our climate system and trying to understand what all those many papers were telling us so they're summarized for policymakers. And so on the left is the 2013 AR5 report. I led chapter 1 in that report. And also about the same time period, Congress passed the Global Change Act, which led to the need for there to be a U.S. national climate assessment. And there's been 4 of those now. We're starting the 5th one at the moment. And I led the first volume in 2017 relating to the science of climate change for the U.S. government. And then the second volume related to the impacts on the American people. And then I've also led there's been a lot of specialized assessments, so I led 2 of them that I think I shared with the university, one on the Great Lakes in 2019, and very recently a special assessment for the state of Illinois that was published in June. All of these assessments are aimed at evaluating how science impacts upon us and what it means to our activities. So to summarize quickly, what they tell us about the science is that our climate is changing. It's happening now. People always, we don't have to worry about climate change, it's happening somewhere in the future. No, it's happening right now. It's causing major issues now. In fact, it's changing very, very rapidly, about 10 times more rapidly than nature tends to change the Earth's climate system. As a result, that leads to both human society and ecosystems having great difficulty in adapting. And that's the real problem with climate change. And it isn't all about warming. I know the media likes the term global warming. Scientists never have, but it's all over the place. Because it's so much more than the warming. It's about the extreme events like I was showing you earlier, and it's about things like sea level rise and the impacts that those have on our society and our coastlines. Why is this happening? It's largely happening because of, almost entirely happening because of human activities. Essential, and really what that means is the burning of fossil fuels, putting carbon dioxide and methane, other gases in the atmosphere. Various human activities are doing those things, but particularly fossil fuel burning, but also land use change. So when we cut down rainforests, or we major changes in our landscape, that tends to have an impact on local climate and potentially global climate if it's significant enough. One thing I can say for sure, the climate will continue to change over the coming decades, but how much it changes really depends on us. And that's what we'll talk about, those policy questions a little later. Now, the most recent IPCC assessment came out a few weeks ago on the science. That's just one of the 3 volumes. The first volume always being on the science, the second on impacts, and the third on policy. And it concluded that one of its conclusions is climate change is already affecting every region on Earth in multiple ways. We'll talk a little bit about all that. And the changes we experience will increase with further warming. So it relates well to the kind of things I've already said. The way we know this, everybody says, oh, it's just models. No, it's not models, it's observations. Observations is what tell us is a major issue. Models help us look at, kind of get us a peek into the future. But we use the models then to evaluate our understanding relative to these observations. And we have observations of things, not only temperature, but precipitation, how the amount of humidity in the atmosphere is increasing. And that's because, again, warmer atmosphere holds more water vapor, humidity levels go up in the atmosphere, and that's observed in multiple different ways. The temperature is increasing throughout the troposphere, not just at the ground level. 92% of the increase in energy from those gases, the carbon dioxide and methane, et cetera, in the atmosphere, what are called the greenhouse gases, is that 92% of the heat that is produced from that is actually ending up in the oceans. So the oceans have a large heat capacity, and as a result, they're actually warming at a little bit slower rate than the rest of the land, as we'll see in a minute, but all that heat's ending up in the ocean. If all that heat came out of the ocean, we'd be in big trouble. But but the oceans are kind of a savior for us to some degree. So there's a large amount of heat going in the oceans. It's well measured, again, by multiple approaches. Snow, things like, and we know the Earth is warming also because things like snow cover are decreasing. Sea ice extent is decreasing, and glacier mass balance is decreasing. Some of those kind of measures, the amount of carbon dioxide in the atmosphere is now the highest level it's been in 2 million years, looking at proxies and various ways of observing those concentrations. So we know that this is a very different situation, and since carbon dioxide is driving, one of the largest drivers of these changes we're seeing, that's really significant. That atmosphere, climate system 2 million years ago was much warmer and had much higher sea levels than the current situation. It had been going on for many, many centuries. We've only been doing this for about 5 decades. The sea level rise is at the fastest rate of increases we've seen in at least 3,000 years, again, using proxies. The Arctic sea ice extent is at the lowest level in at least 1,000 years. And glacial retreat is unprecedented in at least 2,000 years. So this is a very different circumstance than what we're used to, and it's not due to natural cycles. Looking at the global average temperature, we measure temperature with thermometers throughout the planet. I'm not showing you here the satellite observations, but they generally agree. They're just over a much shorter time period. But these observations taken every day, multiple times a day sometimes, are evaluated by a number of organizations around the world, NOAA being one of them. This is the NOAA data set, National Oceanic Atmospheric Administration. NASA does the same thing. There's a group in Europe that does the same thing. And there's actually a group in UC Berkeley that also does this, and a group in Japan. And they all agree that we've seen on the order of a 1 degree centigrade increase, 1.8 degrees Fahrenheit increase in temperature throughout the world. Now, it doesn't sound like much. We see deviations in our temperature every day. It seems more than that. But this is globally averaged, annually averaged. And the last, so if you look at the last ice age, it was about 5 degrees or so colder than now. And yet, for us in central Illinois, there were thousands of feet of ice above that part of Illinois. I can't speak about central Missouri, I have no idea. But it was a very different climate, and yet it was only 5 degrees. So when we start talking about 1 degree, that's significant. We're going to be talking in a minute about the projections, and we're talking about the levels of warming that are comparable to what we saw with the ice, or the previous ice age. So how does this compare with what we've known over the last, what the temperature on Earth's been like over the last 2,000 years? So that's what the bottom graph is about. It takes that graph from above, and the red lines translate it onto looking at the last 2,000 years, where we have proxies for temperature. This is for the northern hemisphere, where we have the most data. And you can see things like the medieval warm period, when we had Vikings living in Greenland. And you can see the little ice age, a couple 100-year period that happened largely because of large volcanic eruptions and because of lack of sunspots. And so the sun was slightly dimmer than it is now. It by no means can fully explain what we've observed, though. And yet you look at the current temperatures, and they're way above anything over that last 2,000-year time period. So the changes we've seen in recent decades are really outside the box of human experience. Looking at this temperature change on the globe itself, most areas show significant warming. Particularly the Arctic is warming about 2 to 3 times faster than the rest of the planet. The oceans are all warming. There's a few areas where we get, and I should say the land masses are also warming faster than the oceans. And there's a few areas in blue, particularly the one south of Greenland, that is due to the decrease in ice in Greenland itself, and also the Arctic sea ice that is putting fresh water into that region and essentially slowing down what's called the meridional circulation in the ocean. And that is of concern because if it were to totally stop that circulation, which is unlikely to happen this century, we would see very different impacts on our eastern coastline and in northern Europe, where they may actually become much colder, even though the Earth generally is warming significantly. Now, I mentioned the extreme events. So generally, heat waves are increasing in number and in intensity. Cold waves are decreasing. Doesn't mean we don't have a cold wave once in a while, we do, but mostly cold waves are decreasing. More precipitation coming as larger events due to that increase in water vapor in the atmosphere. That's happening around the world, almost every location in the world. There's an increasing risk of floods in some parts of the world in particular, where they're seeing the most significant increases, Midwest and Northeast in the United States, for example. And an increasing intensity of droughts and others because of the changes in the circulation patterns in the atmosphere that are driving things like the Southwest and Southeast to become drier. Large wildfires have increased. Intensity of hurricanes is increasing as expected. Tornado activity, we still don't know exactly how that's going to change. There's conflicting information as to whether they will become more intense or not. But we do see more outbreaks of tornadoes than in the past, and tornadoes probably moving into areas where they had not been much before. One of the ways we know that this is a serious problem, I know a lot of Americans think, oh, climate change isn't affecting me, why should I worry about it? It is affecting your pocketbook. You may not realize it, but it affects your taxes. And that's because since 1980, and this is just for the US, but we can look at the same thing worldwide, the NOAA has been tracking what are called the billion-dollar events. And they do that, they account for GDP, and so it accounts for many different things that might be a factor here. But basically, you used to see a couple such events when they first started doing their observations. Now we're seeing 16, 17, this last year, 20 such events. And it's costing the American taxpayer many, many billions of dollars. In fact, over the entire period, it's been a total of 1.5 trillion effect on the American taxpayer. But some of that, of course, would have been natural things that would have happened anyway. But I still tend to argue that maybe it's over $1 trillion that is due to climate change. So it had an impact on you, you just didn't realize it. And it's affected all parts of the country. Now, what's causing climate change? I've already mentioned the increase in carbon dioxide and methane as gases and particles that affect us. But where are these coming from? Many lines of evidence demonstrate that human activities, especially emissions of greenhouse gases, are primarily responsible for the observed climate change. The analysis on the right was from the new IPCC assessment, shows that observed temperature record I showed you before, and shows it with and without the effect of the human activities. Nature itself would not have led to the kind of changes we're seeing, only because of the fact that we're making these impacts on the amount of carbon dioxide and methane, et cetera, in the atmosphere, are we having these changes. We also know for the period extending over the last century, there are no credible alternative explanations if we look at the observational evidence. It's not the sun. The sun actually has decreased slightly in its output, not increased. Yet you'll see in the media all the time that, oh, it's the sun. Somebody will make that broad statement without ever having looked at the data. But it's not the sun. It's not natural cycles. There are no natural cycles that can explain what we're observing. We could talk about the details of some of the things we're seeing, and there some natural cycles do come into play, but not in the overall change. Now, how do we look at the future? We use models to then, based on that understanding from observations, to then have, these are models of the chemistry and the physics and the biology that affects our Earth system, very complex models of all these processes that affect our climate system. And we look at a range of different scenarios for the future. So right now, we've been kind of following these. So these are just various emissions for carbon dioxide on the left and then other gases and particles on the right. We've been following the high scenario up to this point, basically. We've been very, very high emissions. Now, some people suggest, well, you should throw out that high scenario in the future. We're no longer going to follow that. However, unfortunately, there's feedbacks in the climate system where we're melting permafrost and we have all these wildfires that could end up putting additional carbon dioxide in the atmosphere and keep us at that high level. So it's still of concern to look at that high level. But we'd like to get to something much lower than that, where the emissions are much, much lower over the coming decades than they have been. And so we look at this range of other scenarios. And then, so you see number there, the SSPs just stands for the type of scenario approach. But the key number is the 1.9, the 2.6, 4.5, 7.0, and 8.5. We'll talk a little bit more about those in a second. Oops, wrong. And if we look at the resulting temperature change by 2100 for those, the low scenario is the one that will keep us at roughly 1.5 degrees centigrade. That is the key goal of the Paris Agreement and of the United Nations body that looked heavily at climate change, that we should try to keep below 2 degrees and if possible 1.5 degrees. So we pay a special attention to trying to get to 1.5 degrees, which is that first scenario. The 2.6 scenario corresponds to almost 2 degrees. I'm just showing you the average from all the different models, the 30+ different models that have been used to look at this from around the world. Then there's higher scenarios, which are more likely cases. The reality is, right now, we're probably going to end up higher than the 4.5. Maybe more like the 7.0. And there we're talking about a range of between 3 degrees centigrade roughly and 4 degrees centigrade. Much higher temperatures than humans are used to. So almost a factor 2 increase above those, 1.8, factor 1.8 to get the amount in Fahrenheit. So we're talking about a very significant impact if we follow those high pathways compared to the lower ones. Give you another feeling for what that means. We've already seen about 1 degree centigrade, as I mentioned. That leads to more changes, as I already showed you, in the Arctic, on land, a little bit less in the oceans, and that's shown on the upper left. And the models give something pretty similar. If we go to 1.5 degrees, you see even more heating on land, more effects in the Arctic, et cetera. 2 degrees, those are even amplified even further. And if you go one of the higher scenarios, where you're at 4 degrees centigrade, you're talking about an extremely warm planet, and where we're seeing much larger impacts. And it's not, again, it's not just the temperature change, it's these changes in extreme weather that I'm really concerned about. Looking at precipitation patterns, this is for the 1.5, 2, and 4 degrees. And you see the patterns are similar, drying, the brown being drying and the green being wetter, where it gets larger and larger wetter areas and larger drier areas. So we tend to say that the dry get drier and the wet get wetter. That doesn't exactly hold, but depending on the location, but it holds in general. And we're seeing a shifting of the circulation patterns that are kind of changing where that drying occurs relative to the current atmosphere as well. Looking at Missouri, I'm going to kind of tune into Missouri based on the analyses being done actually for the new National Climate Assessment. And we've seen about a 1 degree Fahrenheit increase in temperature in Missouri. It's less than the US's 1.8 degrees. Much of that is occurring at a little bit higher latitudes. Illinois was closer to the 1.8. The more northern states tend to have the largest changes, and the states to the south have the smallest changes. Much of that, like Illinois and Iowa, of that warming has actually occurred at nighttime, not during the daytime. Because of the increase of precipitation, soils have remained moisture, And that has kept the daytime temperatures from really increasing in Illinois as in many other parts of the country. And that's true for Missouri as well. And so if you look at the nighttime temperatures, the minimum temperature, which is the nighttime, you'll see that that's where you get the largest warming amounts. If we look at that temperature record and then say, what are the projections for the future tell us about Missouri, we're talking about, depending on what scenario you follow, something between an increase, and the low scenario here is actually the 4.5. The reality is the 1.5 or 2 are going to be very difficult to reach. So in the National Climate Assessment, we look at the 4.5 and above, though the new assessment actually is going to look at all of them. And then a high scenario is equivalent to 8.5. But we're talking about a range between 2.5 and as high as 12 or 15 degrees warmer in Missouri by the end of the century than it is now. And even at mid-century, we're talking about a substantial warming compared to now. If we look at the changes in precipitation projected, overall precipitation is expected to increase. This just shows the increase in 3-inch storms and in 4-inch storms projected by the model, and showing that you expect a significant increase in each of those. More of that rain, not only an overall increase in rain, particularly in winter and spring, but that more of that rain coming as larger events. Another way of looking at that is to put it on a map, and Missouri annual has a slight overall increase. Winter and spring showing a very significant increase, the most significant increase, and actually a drier summer than in the past. So I'm a farm boy, and so I worry about that drier summer because that's going to potentially impact crop yields. Meanwhile, the temperature's increasing, a lot more drier soils and everything goes with that in the summer. And overall, for all these scenarios, nationally and globally, we're expecting increasing impacts from severe weather. Turning quickly to sea level rise, it doesn't affect us here in the Midwest very much, but it is very important to our coastlines. We've seen about 8 inches worldwide increase, more than that actually on our East Coast, because the land is subsiding there as well. We're seeing more incidents of nuisance flooding or high tide flooding as a result. We can expect to see another 1 to 4 feet of increase this century. And as the graph on the right shows, by 2300, sea levels expected to continue to rise as we get further melting of the ice in Greenland and Antarctica and from the glaciers, and also the warming oceans expand. That sea level rise could end up as high as 7 meters. And that's really worrisome. So by the end of this century, maybe we're talking about 1 meter, and that's worrisome enough, because there's going to be parts of Florida underwater. But as an example, parts of New York City underwater. But if it keeps going, how are we going to plan for that and deal with it is something that's going to require a big effort. Because we're increasing the amount of carbon dioxide in the atmosphere, 25% of that carbon dioxide is ending up in the oceans, and it's turning into carbonic acid in the oceans, and that's acidifying the oceans. It's making them less basic than the oceans normally are. That's affecting shellfish. We already know that. But what it means in terms of the impact over this century and beyond is what's not clear. How is that going to go through the food chain in the oceans is what we're really concerned about, and we don't have much understanding of. And I mentioned the changing ocean circulation already. So the IPCC assessment again concluded that as a result of all these kind of findings, that unless there are immediate, rapid, and large-scale reductions in greenhouse gas emissions, limiting warming to 1.5 degrees centigrade will be beyond reach. And that there's no going back from some changes in the climate system. We're not going to see going back to what we were like in the 1950s or before that for many, many centuries. However, some changes may be slowed and others could be stopped by limiting the warming. So what can we do? We basically have 3 choices. There's a 4th one I'll mention in a minute. But the main three choices are we can mitigate, we can reduce those emissions that are driving these changes, we can adapt, be more resilient to the changes that are occurring by having our human systems and helping ecosystems be able to adapt to those changes, or we can suffer. And right now we're doing some of all three. If we're going to minimize the suffering, we need to maximize the mitigation and the adaptation. And so I'm actually trying to spend the rest of my career trying to look at how I can participate in those kind of activities. There is the fourth element, which is to use geoengineering. Some people have proposed that we put sulfur dioxide in the stratosphere or other means where you basically reflect the sunlight, make it a cooler Earth because we're reflecting sunlight. The problem with that is you're fooling around with Mother Nature, and there's usually some other way that Mother Nature is going to bite back. And we don't fully understand those mechanisms. Should we study it? Yes, I'm fully in favor of studying it, but there's people that want to actually implement, put it in place now, and I don't think that's appropriate. The other important thing, if you actually look at the 1.5 and 2 degree scenarios, they actually require that we start removing carbon dioxide from the atmosphere, not allowing as much to get there in the first place, so we have what are called negative emissions. And there's all kinds of ways of trying to do that, but they're not economically feasible at this point. Hopefully they will be in another 30, 40 years or so, and that could be important in the last half of the century to help keep us at 1.5 or 2 degrees. Now, any additional carbon, this is from the new IPCC assessment, but it's a picture that even showed up in the assessment I worked in 2013. Any additional carbon dioxide you add to the atmosphere has an impact on temperature. So, and this just shows the temperature versus the emissions of carbon dioxide. And this can be done in terms of equivalent carbon dioxide, so it accounts for all those other gases. But basically, it's a near linear effect, depending on how much the equivalent of carbon dioxide increase is and the resulting temperature change. So we got to control the amount of carbon dioxide somehow. So that's one lesson. In 2016, while I was at the White House, the US helped lead us getting into what's called the Paris Agreement, which is the meeting of all the international countries to come together to have an international alliance to try to do something about this. So this was at COP21, where the Conference of the Parties led to the Paris Agreement, and that resulted in every country making a voluntary effort out to 2025 or so about what they would do. And some countries promised a lot, and other countries did not. And, but as we'll see, even with all that together, it didn't really accomplish a whole lot. It got us started. The long-term goal is to keep the global average temperature change to 2 degrees or less, as I mentioned earlier. So hopefully 1.5 degrees. But the other thing that Paris Agreement calls for is a transparency and accountability in knowing what the national emissions are. And that is an important aspect that needs work on, but is an important aspect of this agreement. And all the developed countries agreed to help the developing countries achieve their goals because they don't have the financial or economies to be able to do it themselves. And it was agreed by 195 countries at COP21. The US left it for a few years and is now back in it. This graph shows that if we had continued on the pathway without the Paris Agreement, we would likely be that very highest scenario, and maybe even higher because of all those feedbacks I mentioned. Following the Paris Agreement brings us down somewhat. Right now, we kind of match the 7.0 scenario. If we're going to get to 1.5 or 2 degrees, we got to get to those green or those blue lines down below, which means, and these are only going out to 2040, And so we need very, very rapid decreases in emissions that we're just not doing yet. So pretty soon we got to turn this around if we're actually going to achieve that, because by 2050, we have to be at net zero emissions if we're going to meet 1.5 degrees. It's very difficult to do, but that should be our goal. So I consider the Paris Agreement as establishing a bridge between today's policies and climate neutrality before the end of the century. And so it's a beginning. It's getting us into the process of getting countries to really talk to each other. There are some realities we need to be aware of. Human carbon dioxide emissions are the biggest piece of the problem. About 85% comes from burning coal, oil, natural gas, which provides about 80% or more of our world's energy. And so that is, we've got a big thing to deal with in terms of transferring our energy and transportation systems to not be doing that. And then we got the effects of land use change that I mentioned earlier. The developing countries now exceed industrial ones in total CO2 emissions. China is the first in emissions now. We used to be first for a long time. Not that that's an ideal thing to be, but China now has the largest amount of carbon dioxide emissions in the world. I think we're second still. India is pretty close to us, though. I don't think they've replaced us yet. Global energy system can't be changed quickly. This is something, if you look at energy in the past, it usually takes 40 years or more for the system to change around the world. And that was based on much earlier types of energy systems. Deforestation trends are not easy to change either. They're embedded in economics of food and fuel and timber and trade and development. And a lot of countries are struggling with that, particularly in Brazil, the Congo, some other countries around the world. So achieving 1.5 degrees centigrade with little to no overshoot means nearly net zero greenhouse gas emissions by 2050 and 40 to 58% reduction by 2030. Looking at that, how do we go out to 2050 and essentially eliminate that 30 terawatts of energy? Well, we're kind of on the pathway right now, just the current pathway, of taking care of about 10% of that with, or 10 terawatts of that with renewables, solar and wind. But we got another 20 terawatts and hydropower and many other things that are non-polluting. And so if we look at the current energy use in the world, fossil fuels are very important. Nuclear fission is important. It's difficult to get that to grow unless you get the public to agree to it, and that's been a problem. But otherwise, nuclear fission could be part of the solution. There's biomass burning, wind power, geothermal, solar's kind of left off of here. And there's always nuclear fusion that always seems to be 30 to 50 years out in the future. And new results are very promising, but they still say we're 30 years or more in the future. So that's not really viable yet. So we look at today, we're heavily dependent on fossil fuels, the gray. But if we look at the sun and look at the amount of solar radiation reaching the Earth's surface, and if we took 2% of the land, and whether it's on rooftops or in other means, and devoted that to solar radiation, even at the current best efficiencies, which are around 12%, we can get to 67 terawatts. That's more than what we need to take care of what we need by 2050. So, the graph on the left says even allowing the other ways of renewables to increase, we got a big gap. But on the right, solar could take care of that. Now, solar will require that we have to have some way of storing that energy at night when we don't have the sun, or times when we don't have the sun. There are a lot of ways of doing that. There's a lot of new technology being developed on that, including new battery systems that are advancing like crazy. So I think we can do this. So I think solutions are at hand. Now, what can we do as individuals? I get asked about this all the time, and I think the most important thing we can do is speak up. Vote for the people who will consider this problem to be important and real. Write your representatives. Let them know that this, and I'll stress this is one of the most important issues facing humanity and will particularly have a huge impact on our children and our grandchildren. And I really worry about them more than I worry about us. But there's a lot of things we can do to be more efficient in our own energy use. And I'll kind of leave it with that, but so we can also be thinking about those things as we look out too. Now, climate change is pretty depressing because what it says is we're going to see very significant changes over the coming decades, larger than we've seen already. And we already caused a lot of damage even this year. But I want to leave you with a sense of hope. Our future does depend on how we act to limit climate change. Adaptation is not a choice. Our choice is whether to adapt proactively or respond to the consequences, and that would be unwise. Hopefully we start planning ahead. Adaptation requires focusing on managing risk, but I also think we can draw on our long history of dealing with problems as humans and deal with this changing condition on our planet. I'll leave you with one final quote from IPCC. The climate we experience in the future depends on our decisions now. So thank you, and I'm happy to answer any questions you have. And I'll tell you, the lights make it difficult for me to see people putting their hands up.
And we've got a microphone for questions so that we're broadcasting this and recording it too, so we'd like to get the questions online. Questions?
What is your thoughts on carbon credits, the way we count carbon credits and the sale of carbon credits?
First of all, I'll say I'm a scientist and I'm not an expert on all those kind of the details of those economic questions. There's two major approaches people tend to talk about, which is to either put a carbon tax or doing a accounting system like that where you count credits and trade them and so on and so forth. I've actually written some papers with economists looking at carbon tax. Myself, I think that's a better approach based on their analyses, not mine. But in our approach, all the money that the countries take in gives back to the people. And so it's not, you don't just put it into the coffers, you give it right back to the people. And that way, the poor don't get affected as much as they would with just a pure carbon tax. I think there's a lot of benefits to that. But the whole thing you want to do, whatever approach you use, and that's where I think we need a debate on, is how do you create the incentives that allow us to transfer our energy and transportation in an effective way that doesn't cause great harm at the same time? And that's, I tend to think the carbon tax is the best way, but but that's subject to arguments. Problem I've seen with carbon credits is trying to track them. It just gets so cumbersome.
With the current legislation that's pending that has some climate change initiatives in it, where do you think that will fit on the projections that you have here? Where will that help us?
Yeah, I haven't seen the details in this new bill to say exactly where to put us. It's a lot of it, what they're talking about for climate is adaptation and incentives to get people to reduce their emissions and switch their vehicles to electric vehicles, for example, or to use solar or wind or other alternatives more for their power. Overall, the United States has, and like other countries, will have to move from being a centralized energy system to a distributed energy system, and that's part of the issue here. we will have to figure out how to deal with that. But my impression is it's mostly incentive-oriented and not as much any kind of wholesale approach to demanding things. It's really trying to put us on the road, the pathway. Whether it's doing it quickly enough is I don't know, because I don't know exactly what it's going to call for.
Thank you.
You did not touch much on it, but do you see a path forward for nuclear fusion in terms of energy production? Yes.
Yeah, so we need to first show that we can do break even, yet alone. There's a slight net production of power in the most recent test out of Europe. Lawrence Livermore National Lab, where I used to be 27 years ago, has also come very close to producing very slight amount, but we have to be able to produce very large amounts. And most of the scientists I talk to say, well, that's still another 20, 30 years away. So I don't think that's an immediate solution. It may be by the end of the century as an important source of power, but not right now.
It was 30 years ago that they were saying we need 30 years, you're right. MIT was doing
When I went to Livermore in 1973, they were saying it was 30 to 50 years away. So, and they now still say it's 30 years away. So it has me a little concerned about whether it's really 30 years away.
Well, at least their answer is consistent. We had a question online. More and more airlines are adapting to biofuels to combat climate change. Is biofuel a good solution considering the associated land use change, water use? Is aviation a major CO2 emission source?
Aviation is about 2% or so of the problem. That's going to grow as we move away the land uses of energy. And so I do a lot of work with the Federal Aviation Administration, looking at these issues. And they are heavily heading towards aviation continuing to use jet fuel, but getting it from biofuels. And most other approaches, there's talk all the time about electric airplanes and all kinds of other things, except for very small planes, that's unlikely. Similar things for hydrogen and other things they've talked about. Most likely, we're going to use biofuels for aviation. And they're looking at different approaches of how they can get enough biofuels made.
First, thank you for coming and speaking to our group. Really appreciate it. Question on, I've always struggled with the net zero by 2050.
So am I.
It's hard. And I probably struggle more about it is that global?
Yes.
Yes. So I'm not as worried about the United States or North America maybe complying and getting there. But has anybody done any studies to say, okay, let's assume that China continues to put in the coal burners that they're putting in now. India's doing the same thing.
But they're not. We already know they're buying up have bought up most of the solar and wind power companies in the world. They're getting ready to really transition their entire country. But if we have countries that don't abide, we can't do this. And so everyone has to be part of the answer.
That's what I thought. I just
Yeah,
want to clarify.
absolutely. Yeah. And that's why it scares me, because are we really going to be able to achieve that? We just went through a scare with stratospheric ozone. I started out my career studying stratospheric ozone. And we had a big manufacturer in China, making CFC-11 even though it was totally banned. And the concentrations in the atmosphere went up well beyond what they should have. And we finally tracked it down to who it was. And the United Nations stomped upon them. But that's a big concern here. So even when I was at the White House, I tried to get a group of scientists throughout the government, including many of our classified kind of agencies, to look at how could we provide a check on what countries are doing. You know, are they reporting correctly, or are they not reporting correctly? And I think we're going to need something like that.
Thanks for coming out and speaking to us about climate change, but you had highlighted a few systems out there for carbon capturing, and you made a general statement that right now they're really not cost effective. Are there any that are cost effective at this point in time?
I would say no. There is some pilot plants being built in the Netherlands that they think are very promising. I have the feeling that processing enough air is the problem, that you just can't get enough air to really take care of this worldwide without having, you know, millions of those kind of plants that they're building built. And are we going to put in that effort to do that? I think we got to keep the research going and figure out how to do that more efficiently.
And is there other natural systems out there that we could use to implement?
Well, we can grow more trees, but the problem is more trees means taking up more land, and we got a population that's increasing worldwide, not decreasing, and so how are we going to deal with that? And so certainly putting in more forest will help to some degree, and there's a lot of movements being put into doing some of that, but I think it's very limited because of the amount of land that can actually be moved back into forest.
Just along that, do you think that there's any possibility of algae growth or other densification of photosynthesis that could contribute?
Certainly, there are a lot of people looking at things like algae as being one of the sources of solution. And that still requires a lot of research because of trying to do it efficiently. You can do it for short time scales, but then longer time scales, it doesn't seem to continue. And so there's a lot of research going on in that.
Another question? Oh, all the way up top. Couldn't you all be more efficient and just ask sequentially in the same?
He didn't realize this was a workout.
Well, first of all, thank you for coming over here. You're coming from Illinois, so CO2 emissions were not that bad to come here. That's the first thing. Now, my question is, suppose the
I
president...
do have a hybrid, so I try to save a little energy anyway.
But suppose the president is calling you tomorrow, and you're invited back to the White House, and you get a chance to whisper one thing in his ear to tackle as much as possible this issue. What would be your recommendation right now to the president?
I think it's what I said earlier. Yeah, people ask me this all the time when I go back to the White House. I remember the White House as being a lot of work, and I'm not doing science, and spending long hours, and what am I accomplishing? But I've also told people that if I was asked to go back tomorrow, I'd say yes. It's where you can make a difference, and so if I could do it, I would do it. I think we need something like a carbon tax to really put us on this road to solutions. We need to get the American people using their innovation to really come up with all the right solutions, and they need some incentive to do that. Now, maybe carbon tax isn't the right way, but something that really pushes us forward. It has to be a going to the moon kind of situation where we're really pushing our system to come up with solutions. And I think we can do that. The papers I've done with the economists say, well, the carbon tax may be the best idea. I've had interesting discussions with members of Congress who have different ideas, and I'm not the economic expert to be able to tell them their ideas are wrong. And so they have their arguments with the economists, and I just kind of stay in the background and try to see, well, who's going to win? I don't know. But both of them, both sets of kind of people have the idea that we need incentives, but we need to figure out what the right incentives are.
You mind if I follow up on that? So part of that carbon tax or making people responsible for certain things, yes. On the other hand, if you look at our energy use, yes, we can tax energy use, but then would you tie that tax to where the energy is coming from?
Yes.
So that means...
Yeah, no, it's not the the production of energy, it's where it's coming from initially.
So which
Yeah.
means, talk about Missouri, where what about, somebody help me here, what, 80% of electricity is made out of coal, that as Missourians we would be punished more than whatever other state where somebody is having a nuclear power plant and make it a lot easier, and then would there one or another way be a way to...
We're going to have to figure out, well, that's part of the problem, is
Yep.
how do we as a nation come to the right solutions? You know, there's a lot of discussion in Illinois about our mining, and because coal mining's been a big thing in southern Illinois where I grew up for many decades, and we need a way of helping those people transition to other types of jobs, because that's just not where the future is going to be. And I'm afraid for Missouri, it's going to be something similar.
Other questions from the audience?
Unless you can capture the carbon and not allow it to go in the atmosphere in the first place. Then that's fine. Then burn coal, all the coal you want, and just capture the carbon. But that's not so easily done at this point yet. We don't quite have the technology to do that.
Hi. So my question is, how do you feel media plays a part in people's perception, contribution, and overall impact of climate change? Do you think there needs to be a social change to help combat climate change in both our everyday lives and the media's influence perception of the topic? If so, what do you suggest?
I've heard for years that people think, oh, well, you're saying we got to totally change the American lifestyle. And I don't think that's the case at all. I think we have the solutions at hand that say, you know, we can use vehicles, we can have energy as we know it, not going to affect our lifestyle really, but there will be some changes. And it will mean that instead of driving a vehicle that runs on gasoline, you're driving one that runs on electricity. And then we'll have a mechanism in place that are beginning to be built for how you then fill up with, reload the batteries. Some of that technology was still being sorted out, but I don't think we're talking about a major change in lifestyle. I think we're talking about small changes that people will adapt to pretty quickly.
We had a question online from one of our alumni. How long do you predict it will be that we still use fossil fuels as a main energy source? And do you think we'll always use those in some capacity?
I really think that we'll come close. We may not make net zero by 2050, but I have a feeling that we're going to come close. And that pretty much means that we will have moved our technology away from fossil fuels. I think we're already beginning to see that happen. I see the pathway occurring where over the next 5 years, I think we'll start seeing a strong movement away from gasoline engine vehicles, cars, and SUVs to battery run SUVs. It might first be through the hybrids like I have now, or it might just be, you might see a sudden switch to electric vehicles. So I think, and almost every major auto company in the world is building electric vehicles and planning on that taking over pretty quickly within the next 5 years or so. So I expect that we're going to see a very rapid transition there, and then we're just going to have the leftover vehicles, and there's always going to be people that want to collect the old gasoline vehicles. So there'll be some gasoline type vehicles around, but not very many. And so largely we're going to move away. And I think it's going to happen with electricity too.
This is just a quick add-on. Would we have a dual system of fuel where we've got electric recharging stations and petroleum recharging stations? And that's
for a while we will.
That's a lot of infrastructure.
Yeah, I know. And for a while we will. I think that is true. And that's why the government comes in terms of getting the charging stations in while we're still making that transition. The other thing that's likely to happen is with large trucks, they're talking about using hydrogen fuel. And so we're also going to have to deal with large trucks having a hydrogen system where they actually produce the hydrogen on site, largely from methane, where they dissociate the methane and get hydrogen, and using solar to help drive that, and then putting the hydrogen into tanks. and then transferring it to the vehicles. Toyota and a lot of major trucking companies are in the process of looking strongly at that transition and making it happen quite soon.
That's a lot of civil infrastructure for us.
Yeah.
Other questions in the crowd?
Kind of related to that, will we be facing a issue with mineral limitations, building the new infrastructure, and specifically with batteries?
Yeah, so that has been a big concern, that minerals, what minerals could affect us. I did an analysis of hydrogen impact on the climate system, when was it, 7 or 8 years ago with one of my students. And at that time, the kind of systems they were talking about required some pretty expensive minerals to be in the reduction of hydrogen within the vehicle. Now they're the thinking has totally changed, and they don't require those minerals. And the new approach, even if you were to do that kind of production, don't depend on those really expensive minerals. Solar does not require the expensive minerals. It uses silicon mostly. There's some small amounts, but as we have enough solar that you start recycling the system, and I think we'll eventually have to do that, we can recover those. And then, so what else was I going to say? Oh, most of the things we're looking at, batteries now, are turning towards much less expensive approaches that don't require some of those heavy, expensive minerals. So I think in the long term that will be the approach, and we will not depend on those minerals as we do right now. That's where all the new technology coming along is being put, is looking at the research in those directions. So I think it's, there's a lot to be done there yet, but I think it's doable. Meanwhile, we can start now. There's a lot of things we can do now without getting into that.
What do you think of the future for hydrogen? You talked about the bigger trucks using hydrogen, but do you see that as a possibility for using hydrogen in the future, maybe even converting fuels using hydrogen, such as microgel beads and things like that, since there's no battery requirements for that?
Right. No,
as an efficient option.
And when we were looking at that for Department of Energy, they were assuming all vehicles would switch to hydrogen. And maybe that'll still happen, but right now, most people talk about batteries as being the standard passenger kind of vehicles and smaller trucks, and at big trucks switching to hydrogen. So I'm not an expert. I do climate science. So I can answer those questions a lot easier than I can answer questions about where this new technology, because I'm just basing it on what I read and what I learned from talking with other technologists.
Yeah, I was just saying also with the hydrogen is more of a fuel than a recharge, especially
No, exactly.
for like farming and more fuel intense.
If you just poured water in your tank and then could produce the hydrogen, that would be really cool. But right now, that's not so easily done.
Other questions from the crowd here? I had one myself. We're talking about adaptation, and you said two, one preemptive and one responsive. In answering in a long about way, what do you see as the biggest preemptive and the biggest responsive? We're going to have to deal with like ocean levels rising. And when you say civil engineering is about the best profession to be in on both cases?
Civil engineering certainly in a sweet spot for that research. The other areas of engineering as well, but I think particularly civil. So I think sea level rise is where we're really going to face some major issues with something's going to happen and we're going to have to face the disaster afterwards. We're also see it sometimes with extreme storms and some of the extreme rainfall. People are starting to plan better for future heat and rainfall events, but that's just beginning. You know, many of the rules that engineers use are still based on the past climate, not the projected climate. And so it's still right now, I think, a major issue in engineering. And hopefully we're in the process of changing that.
I know there was a projection that New York City's investing $20 billion in preemptive measures after Sandy and some of the other storms that really hit, like the infrastructure and the subways.
Yeah, the problem is we tend not to spend the money until we have to. And so but this is a case where we need to start thinking ahead, or else we're going to spend a lot more money. And sometimes as we're building new infrastructure, it's really not much more expensive to build it having thought about what the future might be like than it is to have based everything on the past.
And another question from an alumnus, surprised to see the huge percentage of CO2 and carbon emissions from concrete, steel, and infrastructure production. Has that gotten much play? Is that a prime area?
Oh, that's very important. Yeah. Bill Gates is actually putting a lot of money into finding solutions for the issues with concrete and cement. And we do need a solution there. I've heard of new techniques that are supposed to greatly reduce those emissions, but I have to admit I don't really know much about them. We have an expert here who could probably tell us.
Yeah, I know we've got some work on decarbonizing the concrete industry. Yeah. Other questions from the audience? Where? Oh, there we go.
I would address the question of case studies on energy building use, insulation levels, HVAC systems, orientation of the building, color of the walls, color of the roof, and energy budgets in BTUs per square foot. I know the energy codes really and truly, I don't think personally have been applied the way they should be.
No, those are part of, when I was talking about most of them are based on the past, that includes those.
I would suggest case studies be done on this campus with the geothermal system that's been put in compared to the power plant that was there, compared to a new building being built across I-44. Now, I've heard of a device in Iceland. It is a CO2 capture device.
Yeah.
Again, I'm with you, like, okay, you suck up all the air in Iceland, but what's that do for the rest of the world, as far as that's concerned? I really think we need to look at that building science part of it and have energy budgets for buildings.
Right.
And put in place something like the National Renewable Energy Lab in Colorado and get one here in this area and be a subsection to that organization. I think there are tremendous abilities for improvements to be made in this area. And I just think personally case studies on some of the buildings on this campus would be a good way to start.
I fully agree with you. A colleague and I just did a chapter for the new ASHRAE handbook. ASHRAE is the heating and refrigeration, air conditioning folks of engineers across the country. And they finally, in their updated handbook for engineers, put in a chapter on climate change and are going to adapt their recommendations for how they look at future heating and air conditioning to be based on what we say about the climate. So hopefully we're in the beginning stages of making some of that happen, but it's really important. I agree with you. Infrastructure is an important part of the adaptation.
Huge part. We need to fix that, Stuart. ARCI program. Other questions? One more here.
Hello. Basically, what I wanted to ask, you had talked about earlier in the lecture this morning about different biases to the public, about climate change not being real, that kind of thing. is there, you being a scientist, is there any way we could convey the facts to the public in like an easier manner? Media influence, like Facebook, that kind of thing, things get kind of mixed up here and there.
Yeah, the problem is there are people who purposely put out misinformation, and the public does not know who to believe. The scientists who are trying to express our understanding of the facts and how the world works are these people putting out the misinformation. And we have struggled with how to deal with that for several decades now. We just don't, we don't have a full answer because we're scientists. We're kind of nerdy scientists, and we don't, we're not great at communication, even though we work very hard at it. I certainly do, and some of my former students, like Catherine Heo, have become quite famous for being communicators. But it continues to be a struggle of how to deal with this misinformation out there. Steve Koonin from NYU, who was at BP, British Petroleum, puts out a book, and it's full of misinformation, and it's just wrong. And I've had my personal arguments with him about those same arguments in the past about those things he's talking about, and he repeats it over and over again despite the fact he knows better. How do you respond to that for the public who then sees this stuff and doesn't know whether to believe what IPCC says or what Steve Koonin says? And it's a struggle. And so I don't have a great answer. It's just something we continue to struggle with. That's part of the reasons where educating our legislators, our representatives, and getting them to look seriously at this, I think, is really important. Okay, well, thank you all.
I had one.
Oh, yeah, a question? Sorry.
So I know you said like planting more forests is kind of unlikely to be a great solution in the long term because we're going to have a larger population booms coming up, and But do you think maybe like integrating more vegetation into cities could potentially be like part of the solution? Just like including more trees for shade.
Yeah.
And
there's a lot of talk in Chicago and other cities about more green roofs, more trees, more plantings, more parks where you have water holding so you could deal with some of the rainfall issues. I'm trying to work with some people who do modeling of the city itself and putting in the climate information into that so that we can try to come up with the right green-based solutions. And it's ongoing work, but yeah, I'm very hopeful that will be part of the answer.
And kind of to maybe put a wrap on it, how big of an issue is our social and political willpower to actually do what's needed to be done nationally or globally?
Well, that's what I tried to imply earlier. I think that's really a major part of it is, we can solve this problem, but do we have the willpower to do so? And like a lot of things in life right now, we need to have that willpower. And yet this is one, I don't think, we see effects now. Those effects are going to magnify by a huge amount over the next 10 to 20 years. And so I really worry about what that means to us as a society. And we got to be thinking about solutions now. And so we got to somehow get across that information, get past the misinformation, and get to those solutions. And we got to figure out how to do that together.
Yeah, we have the willpower to go to the moon, but will we have willpower to protect our own planet?
Yeah. Yep.
And I think we've come to the end of our time. Thank you all for joining. I hope this was a great investment of your time. And thank you so much for sharing of your time, your talent, and your background research on this, because that was very well put together and very well presented to
thank you.
The audience.
Yeah.
Thank you.
So I'm here as an educator. I want to make a difference. I want to help people. Students asked me this morning what drives me, and I'm very goal-oriented, and I want to make a difference, and I want to make this a better world. And that's what drives doing talks like this.
Awesome. And that was one of the questions that we didn't get to, is one student said, how can I make a difference? And I think you're looking at one person who is making a difference, and that's what we can all aspire to. Thank you again. And that concludes the 2021 Stueck Lecture Series. Thank you.